This is the last lesson for transformations. We're going to be taking our transformations that we notice with our absolute value function. So here's the general form of that absolute value function, and we're going to be applying it to transformations that don't necessarily look like a regular function that we're typically used to. So I would just want to recap all of our translations really quick. I know we didn't talk about parabolas yet, but it also is the same for parabola, but the letter that shifts our absolute value function horizontally is the h value. Remember, if h is positive, it shifts it to the left. If h is negative, it shifts it to the right. The letter that shifts the absolute value function vertically was the k value. Now when we saw our absolute value functions, we had this written where k was on the other side, so it was plus k if I bring it over to the other side. So this number here shifts it up if it's positive and shifts it down if it's negative. The letter that turned the absolute value function upside down was also the same letter that either stretched it or shrunk it, and that was the a value. Okay? So those three principles here that we were looking at with absolute value functions are now going to help us when we have a graph that looks like this, where this doesn't follow necessarily, you know, a general mother function. So here we've got just an example with f of x. So this function is titled f of x. Now we're trying to graph f of x plus 4. So this is mimicking what we're seeing when we have a value inside like this. Okay, so x minus h. This is the same idea here. So we know that this is going to shift horizontally, and in this case you're going to shift everything to the left 4 units. This affects your y, or sorry, your x variable. So this affects the x. Okay, so a horizontal shift will affect your x values. Now, of course, I could just come over here and take every point and translate it 4 units to the left. So I would go 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the left, and 1, 2, 3, 4 to the left, and just draw my points this way. And that is the same graph shifted horizontally 4 units to the left. But that's not going to help me when I get to more complex diagrams and when I have more than just one translation. So what you're going to have to do is create a general table. So in order to do these algebraically, or with using a table, you are going to create a table using the 3 points here, here, and here. So you only really need the distinct points of the graph. You don't have to find every other point on this graph, just the distinct points that kind of give you starting points for each line. So if I were to figure out the coordinates, this would be -3, 5, -1, -2, and 6, 3. Okay, so I'm going to write out my table here with x and then y, and write down each of these points. Now, I know that, again, this shifts it horizontally and it affects the x coordinate. So what I'm going to do is create a new table where I take my x and I change my x. So this little triangle just means change. So it's just a change in your x value, and the y value should be the exact same. So the y does not change when I have a shift like this, right? The y does not change at all, so I keep those numbers the exact same. Now in the first column, I'm just going to recopy the original points, just like that. And then the change that I need to occur, remember, if this is positive 4, this actually shifts it to the left 4. So I'm going to subtract 4 from every x number. So that's the change that I'm creating here. It's the translation. So I subtract 4. -3 minus 4 gives me -7. 6 minus 4 gives me 2. -1 minus 4 gives me -5. So you just have to be really careful about your signs and the values that you're putting in here. So what I do now is I actually graph this new point. These new points found from the change after I applied that horizontal change in the x, and I keep the same y value. Those are the points that I now plot. So if I go to -7, 5, and up 1, 2, 3, 4, 5, here's my first point. If I go to 2, 3, 1, 2, 3, and if I go to -5, 1, 2, 3, 4, 5, -2, you're going to notice that this shape has the exact same shape as your original function here, but it's just been translated 4 units to the left. Okay? So that's how you would do that using a table. So let's look at the next translation here. Okay, so here we have a graph g of x. Okay, so this function here is not, again, like an absolute value function. It's just some function that's drawn in. I want to take the important points here. The important points are these here that define this function. So you don't have to do every single point, just find the 4 points in this case that define this function. So I'm going to do that really quick, find the coordinates. Okay, so here are all my points written out, and I'm going to go ahead and fill out this table as well using those 4 points. And now I want to look back at this original function and the translation that's occurring. So remember that when the number is outside of the parentheses, when you have, in this case, this -3 is afterwards, it's sort of like this k value, okay? This k value here, outside of that parentheses or outside of the absolute value, is going to affect the graph by shifting it vertically, okay? So there's a vertical shift here, meaning up or down, and this is going to only affect the y coordinate. Okay, so a vertical shift only changes your y, it does not change your x. So in this case, when I make my new table, I'm going to reflect the fact that the x stays the same. So my x values, I just steal all of those x values. I still write my y value, so 5, 1, 1, 3, but now I'm changing the y value. Okay, so I need to change the y value, and in this case, you're going to keep that sign here because it's going to shift this down, right? This is a shift down 3 units. And that means I'm going to subtract from this y column, I'm going to subtract 3. So the new y coordinate, after I do 5 minus 3 gives me a 2, 1 minus 3 gives me -2, 1 minus 3 gives me another -2, and 3 minus 3 gives me 0. This time when I plot this is where you got to make sure you understand the whole concept. You're keeping your x value, right? But we just changed our y to this coordinate. You're keeping your x, you're changing it to this y. You're keeping your x and using this new y, keeping this x and using this new y. So those are the points that I am now going to plot. So I go to -4, 2, 0, -2, 4, -2, and 8, 0. So this is that function g of x that has now been shifted 3 units down. And you can also see over here, if I just shift these down 3 units, I get that exact same graph, right? Okay, so you might be asking, why am I doing this whole table if I know how to shift it down completely? Well, once we get to the newest one, like this, now it's really important to understand what those tables do, okay? So now it's still only one translation, but this number out in front of h of x, this is like the a in your absolute value, okay? So the a value here is what stretched or shrunk or flipped it over the x-axis. So this number here, we should see a flip, right? We should see it reflected over the x-axis, but we also have a 2 here, which is going to stretch the values. So this is a stretch and a reflection. Now, the actual value that this affects, though, and this is really hard sometimes for students to understand, this only affects the y, okay? So a stretch and a reflection only affects the y coordinate. It does not affect at all the x, okay? So even though it's, it looks like it's multiplying the x, it doesn't actually multiply the x, it affects the y. This is really the most important thing to get out of today, is understanding what affects what. So in this case, the a value, or a number in front of your function here, is going to only affect the y coordinate. So again, I make my table. Okay, so I went ahead and I just plotted all those points, or I figured out where those points were, and I made my table here. I don't actually need to do a brand new table. I've been doing that to kind of help explain this, but remember, it's only affecting the y, so I want to change in my y value, right? That's going to be the new, this column here is going to represent all the new y values. So we have to think about what this does. Well, all that your number in the front is going to do is multiply your y coordinates. So I'm going to change this y here by multiplying each value by -2. Okay? So now that means the new y is going to be -4. After I multiply 2 times -2, I get -4. And if I multiply -2 times -2, I get a +4, and then another +4. So when I go to graph this, remember, you're graphing your same x value, so the same x value with this new y. this x value with this y, this x value with this y. So when I go over here to graph, at negative 6, negative 4, 1, 2, 3, 4, and negative 1, 4, and 5, 4, 2, 3, 4, 5, 1, 2, 3, 4. Now you're going to see this has been flipped, right? Now you're seeing this whole thing flipped over the x-axis, and it's also been stretched vertically, right? You have a vertical stretch. This segment here is much shorter than this segment here, so it's been stretched and flipped, okay? All right, the very last one here has two transformations. Oh, sorry, example 4, we still have two more to go. But we have two translations here now. We have a translation right here and here. So I want you to think of order of operations before you even start your translation. Whenever you make your x and your y column here, you have to think of order of operations. So the first transformation that occurs, because I would multiply values before I would subtract values, is here. So we have a change in the y, right? Because again, this number out in front, it's a negative 1, but it affects the y. Okay, so a change in the y, we're going to multiply the y by negative 1. And we also have another change in the y. This also affects the y coordinate. It subtracts the y by 3. So we're going to subtract the y by 3. Subtract y, oops, by 3. Okay, so again, two different effects that happen to the same variable, to the y. So when I write my points, and I'm going to go ahead and make my xy table here. Okay, so I'm just filling out the rest of this table here. It doesn't really matter the order of the points that you put them in at all, but I'm just going from left to right basically. So I have this point first, then here, then here, then here, then here. It doesn't really matter though how you actually set that up in your table. Okay, so now that I have the coordinates, remember we have two different translations that happen to the y value. The first one though has to be the multiplier by negative 1. So we have two different changes in y. I'm going to denote that by change in y1 and then change in y number 2. Okay, so the x values here are going to be the exact same. What you're going to end up graphing here are those exact same x values, just that your y values are now going to change. So the first thing that I do when I change this y is multiply by negative 1. So I multiply every single number in this y column by negative 1, so I get negative 4, positive 4, negative 2, positive 4, and negative 4. Okay, so that's the first translation. The second translation says subtract each of those y values by 3, because now we have this back up here. This is, remember, a vertical change in your y value. So we're going to keep that same sign, just subtract 3 from each one. So I take that same one that I just found. So I now am applying the transformation to the new y value, which is negative 4. And I subtract 3 to get negative 7. I subtract now this next term, 4 minus 3 gives me 1. Negative 2 minus 3 gives me negative 5. And 4 minus 3 gives me 1. Negative 4 minus 3 gives me negative 7. So these represent now, after I've applied that second translation, these represent the coordinates that I'm now going to graph. So I go to negative 6, 1, 2, 3, 4, 5, 6, down to negative 7, 1, 2, 3, 4, 5, 6, 7. I plot negative 2, 1, 0, negative 5, 2, 1, and 6, negative 7. And now I just connect these points. So this is the original function j of x has now been reflected and translated down 3 units. Okay, the last one here, if you guys want to try this one on your own, you can pause the video and try this one, and then play it back if you match it up to the key and it doesn't really quite make sense. Okay? Alright, so I'm going to start with my xy table, my normal xy table. I have 3 points here, negative 2, 4, 0, negative 3, and 2, 4. Okay, so let's take a look at the different translations here that occur. You have a negative 2 out in the front, and this plus 3. So let's talk about which one would happen first. These are both changes in your y value, and this is the translation that will occur first. So the first one is a reflection and stretch in your y value by a factor of 2. Okay? The second translation that occurs is this plus 3. This is going to shift the graph up 3 units. Okay? And again, both of these are changes in the y, so it only affects the y coordinate. So we keep the x coordinate the exact same throughout. We're only going to affect the y coordinate. So we have 2 changes here, change in y1, I'll call that y1, the little sub 1, and change in y2. So in change in y1, I want to multiply every value by negative 2. So I take every single number in my y column and I multiply them by negative 2. So I end up with negative 8, positive 6, and negative 8. Again, I'm multiplying these numbers here by negative 2. Now my second translation says to shift it up 3 units. That means I'm taking this and I'm adding 3 to every y value. So I use the new number here, this new number, and I make that an translation by adding 3 to each of those. So I end up with negative 5, negative 8 plus 3 is negative 5, 6 plus 3 is 9, negative 8 plus 3 is negative 5. When I go to graph this, I now use these values, right? The x stays the same, but this is my brand new y. So I go ahead and I plot these, negative 2, negative 5, and 0, 9. This was off the graph, that's okay. And 2, negative 5. And this function, although it kind of maintains the general idea, right? It's still a V shape. This has really been stretched, so it's going to be obvious if you just kind of guess and try to, switch around your values. This shape here is much different now after we've applied those translations, and the only way to do that is to make sure you understand how to get those numbers using your tables. Okay, this is the end of the lesson for Transformations Day 3.